Hey, hello and welcome to today's GFG problem of the day. Hope you're doing well. So let's say today's problem by height of binary tree. Okay. So what the problem is saying is we'll be given a binary tree and we want to find its height. Now the height they are saying we have to return in terms of the number of edges on the longest path from the root to a leaf node. Okay, a leaf node is a node that does not have any children. Okay, so here is an example binary tree. Okay, so here is a root node, right? Okay, and what you want to do is you want to find out the maximum height of the binary tree, and that maximum, like how we need to calculate the number of edges from the root to the leaf, the maximum number of edges, for example, which is what is the maximum height here, or what is the height of this binary tree? It is 2. How? Because if you see, right, what is the longest path? Longest path is from 12 to 8, that this is one edge, and 8 to 5, this is the second edge. Or you can consider 12 to 8 or 8 to 11. Okay, any two of them. Okay, any of them. Okay, so this is what we want to do. So what we want to do is we want to calculate the height of the binary tree in terms of number of edges. Okay, okay. Okay, now what are we going to do? We are going to use DFS in order to solve this problem. So what we're going to do? So when we will start iteration from the root, okay, we'll go to the left of the binary tree. Okay, we're going to check does 8 has left child? Yes, it has. So we're going to go to the left. Okay, now 5. So here we go to the left, but here there's no node, right? There's no children. So what we are going to do? We are going to return -1. Okay, if the problem had asked us to calculate the height in terms of number of nodes, so we would have returned 0 from here. Okay, but since they're asking in terms of number of edges, so we're going to return -1. Okay, -1. Okay, so 5 does not have left child. When we go to the left of 5, so this the child is null, so we're going to return -1. Okay, so okay, so from here, when we go back, right? Because okay, now again, this 5 does not have right child, but still, if you go to the right to right of 5, so you're going to return -1 here. Okay, -1. Okay, now we have processed both the left and right path of 5. Now it's time to go back to 8, right? Go back to 8. Now, when we go back to 8, what we're going to do is whatever left and right child of 5 had returned, right? We are going to take the max, okay, max of left r, and we're going to add +1, +1, +1. Consider this edge, right? Consider this edge. We're going to return +1 to 8, right? So what is L for 5? It is -1. R for 5 is -1. Okay, if you take max, okay, which is -1 again, and we're going to do +1 here. So -1 plus 1, it is going to be 0. So we are going to return 0 here. Okay, we're going to return 0 here. Okay, when we go back to 8. Okay, now we have done processing the left path of 8. Now we'll go to the right path of 8. Okay, so here we go. Okay, 11 is there. So we're going to go to the left of 11 now. Once we reach to 11, there's nothing. So we are going to return -1. Similarly, from right of 11, we are going to return -1. Again, -1, -1. The max is -1 plus 1 we are going to return, which will be 0. Okay, which will be 0. Now 8, right? So we are done processing the left and right path of 8. So what are we going to do? Max of left of 8 plus right of 8, which is both are 0, right? 0, 0, right? And +1 we are going to do. +1. So 0 plus 1, 1. So we're going to return 1 here. Okay, we're going to return 1 here. Okay. Okay, now we are done. Okay, now we are done processing the left child or left path of 12. Now we're going to go to the right path of 12, right? We're going to go to the right path of 12. So we go to 18. Again, from 18, we are going to go down further, right? As we are traversing using DFS. So we'll go to the left. There's nothing in the left of 18. We are going to return -1. Okay, similarly, from the right of 18, we're going to return -1. And okay, and then we are going to take max out of these two, which is -1, and +1 we are going to do to that. We're going to do +1 to that. So -1 plus 1, it is going to be what? 0. So we're going to return 0 here. So we are done processing both the left and right path of 12. Now we're going to take what? Max of 1 and 0. This is from the left path of 12. This is from the right path of 12. And +1 we are going to do. +1 we are going to do. What is max? Max out of these two is 1 plus 1. So we are going to return, in the answer we are going to return 1 plus 1, which will be 2. Okay, and hence the answer 2, right? What is that? For example, we have written 12, right? We have written 2. So how it is? So our tree was like this, right? Our tree was like this. So 1 and 2 in terms of edges, right? In terms of edges, height in terms of edges. So it is 2. And hence our approach also written 2. Okay, so this is the intuition behind solving the problem. I hope you've got the intuition. Now let's go and code. Before going to the code, I'll just request you to please subscribe to the channel, like the video. Okay, now you'll understand better. So what we're going to do, first of all, the base condition is, or let me write first, we're going to iterate to the left path, right? Or the left children. Node dot left, we are going to go. So first I'll show the Java code followed by C++. Then what? We have the R, let's call it maybe L height and R height. And we are going to go to the right side. And then what are we going to do? We are going to return the max out of both, right? Out of the left and right child. So L height and R height will say, and plus 1, as I have already explained in the intuition. Okay. So here, now what will be the base condition? If node is null, if there's no left or right child, right? Then we have to return, as I've discussed, -1. Okay. So this will solve your problem. This will give you the height in terms of edges, I would say. Okay, some issue. What is the issue? What is it saying? Method DFS. Oh, my bad. So this is height only. Okay. So what will be the time complexity? It is going to be of n because we are iterating all the nodes. Okay. So all the tests has been passed. Thanks for watching. Please don't forget to subscribe to the channel, like the video. Let's quickly see the C++ code as well. So not much difference. Only difference is arrow we are using here and we are using null PTR. Whereas the code is same. Okay, thanks for watching. I'll attach the code in the description section. Please subscribe to the channel, like the video. I wish you a very happy, healthy, wealthy, and a great day. Thank you so much.